Hello everyone. So welcome. Today we are going to try to find reduction formula for the integral of dx all divided by sine to the p of s cosine to the q dx. Now here we are going to try to write this. We are going to try to write this as the integral of this instead of because 1 over sine of x is cosecant of x, and also 1 over cosine of x is secant of x. So we can try to write this as the integral of secant to the m of x and then cosecant to the n of x dx. Now another thing that we want to do is that we want to use integration by parts, which that is what you use most of the time when you're trying to like look for reduction formula for integral. So in this case now we are going to take u as tan x here, and then v to be secant to the m minus 2 of x, and then cosecant to the n of x. And the reason for this choice is that if we differentiate u, because the integration by parts formula said that the integral of u, the integral of v du is equals to uv minus the integral of u dv, or v du. It doesn't matter whether it's the v you write here, you just have to write du here, everything will be correct. Now if we put this, now technically that if we take the derivative of u, you have secant squared x. Now that will give you v, which is this expression. If you multiply by du secant squared, you will have secant to the m of s. So in this case you will get this expression. Then that means we have set up everything right. So what we have is that this integral, this integral here should equal uv minus u dv. So let's go to the next page. So we are looking at the integral of tan x, the integral of secant to the m of x cosecant to the n of x. We say this is equals to u v, that is tan x, times what, times secant to the m minus 2 of x, and then cosecant to the n of x. So we are going to subtract the integral of tan x multiplied by the derivative of secant to the m minus 2 of x, and then cosecant to the n of x dx, obviously. Now let's look at the derivative here. Let's take u, let me change pen. So let's take u to be, our u is secant of x. We're looking for derivative of that, so we're looking for derivative of secant to the m minus 2 of x, and then cosecant to the n of x. So the derivative here would give you, what's the derivative of secant of x? That is it's secant of x tan x. So we have m minus 2 times secant of x times tan of x times what is derivative of that would be m minus 3, that would be secant to the m minus 3 of x. Now we're going to multiply this by cosecant to the n of x. Then what is the derivative of cosecant to the n of x? That is the on. So we have plus, no, instead you have a minus n, cosecant to the cosecant times cotangent of x times cosecant to the n minus 1 of x times secant to the m minus 2 of x. So when all this is said and done, this should be equal to, you have m minus 2, this is equals to m minus 2 times now secant and secant here, so this will be secant to the m minus 2 of x. Then here tan of x, so that is tan of x cosecant to the n of x, minus, now this will be n cosecant to the n, so that will be n secant to the m minus 2 of x. Then you have cotangent of x times what, times secant times cosecant to the n of x. So this will be the derivative of this. So this is what should go here. So if we distribute tan x, so we will find out that the integral, let's use so what we'll find out is that the integral of secant to the m of x cosecant to the n of x is equals to tan of x first of all, and then secant to the n minus 2 of x times cosecant to the n of x. So minus now, so you have the integral of tan of x multiplied by the first part here. So tan of x multiplies everything here first. So we have m minus 2 times secant to the m minus 2 of x secant to the m minus 2 of x times tan of x cosecant to the n of x dx. Also we are going to subtract n times the integral of tan of x. We multiply cotangent of x, and then secant to the m minus 2 of x, and then cosecant to the n of x dx. So interesting thing happen here is that the tan the tan of x and cotangent of x cancel out, so we're left with secant to the n minus 2 of x and cosecant to the n of x here. And on the other hand here, tan of x and tan of x here, you have tan squared of x. So this should equal, what we'll have is that no space here. Okay, let me go back to the next. So we have, let me take out this part. Okay, hold on. So from the previous page, we have that the integral of secant to the m of x cosecant to the n of x is equals to, so there we have tan of x multiplied by secant to the m minus 2 of x, and then cosecant to the n of x. Then we are subtracting first of all the integral. So from the previous page, we see that this is tan of x multiplied by, so tan of x times tan of x will give you tan squared of x. So we have tan squared of x secant to the n minus 2 and cosecant to the n. So we have tan squared of x secant to the m minus 2 of x, and then cosecant to the n of x. Okay, let's not forget m minus 2. So you have m minus 2. So we also have to subtract n times the integral of now for this part here, the tan of x and cotangent of x, they cancel out, so you have secant to the m minus 2 and cosecant to the n. So you have secant to the m minus 2 of x and cosecant to the n of x dx. Now tan squared x is secant squared x minus 1. So let me get different color. So what that should give us is that this whole integral does equal tan of x times secant to the m minus 2 of x cosecant to the n of x minus m minus 2 times the integral of see, if you write it as secant squared x minus 1, so you have secant to the m of x, secant to the m of x cosecant to the n of x plus m minus 2 times the integral of what secant to the n minus 2 of x cosecant to the n of x plus minus n oops, hold on, I hope we don't miss a minus sign here. Okay, if we distribute, when we distribute, the margin is a minus, so when we distribute, minus and minus is going to be a plus. So this is supposed to be a plus sign here. So we have a plus n times the integral of secant to the m minus 2 of x and cosecant to the n of x dx. Of course, dx and dx here. Why not? So hold on, let's see. I thought I changed color. Okay, let's try this one. So basically now, this means that the integral of secant to the m of x cosecant to the n of x dx is equal to, then we'll have tan of x times secant to the m minus 2 of x and cosecant to the n of x, or minus m minus 2 integral of secant to the m of x and cosecant to the n of x dx, plus m plus n minus 2 m plus n minus 2 times integral of secant to the m minus 2 of x and cosecant to the n of x dx. So if you notice here now, we see that we are onto something now. Like this integral here and here are the same, so we can move this to the left hand side, and I think we're going to get m minus 2 plus 1, which is m minus 1. So what we have now will be that, so therefore it means that let me take it means that, so it's okay. So this means that m minus 1 times the integral of secant to the m of x and cosecant to the n of x dx is equals to tan of x secant to the m minus 2 of x cosecant to the n of x minus m plus n minus 2 times the integral of secant to the m minus 2 of x cosecant to the n of x. So you can see that we are onto something now, because here we have officially reduced the power from m to m minus 2. So basically this means that the integral, so let me write it a different color, shall be better. So this means that the integral of secant to the m of x cosecant to the n of x is equals to tan x times secant to the m minus 2 of x and cosecant to the n of x, all divided by m minus 1 minus m plus n minus 2, all divided by m minus 1 times the integral of secant to the m minus 2 of x and cosecant to the n of x dx. So what have we done here? We have successfully reduced the power from m to m minus 2. Let's say, for example, now we're dealing with the integral of let's with a different color. Let's say, for example, now that we're dealing with the integral of, let's say, secant cubed x cosecant to the cosecant squared x dx. So in this case now, m is 3 and n is 2. So we're having m minus 1 is 2. So this will be equal to tan x secant to the 3 minus 2 is 1, secant of x and cosecant of cosecant squared x, all divided by 2 minus, now m plus n is 5 minus 2, that is 3, minus 3 halves times the integral of secant to the secant of x times cosecant squared x. So you can see that beautifully, instead of dealing with this complicated integral, we're not dealing with a power less. Although this formula fails if m is equals to 1. So we cannot use this formula again, because here m is 1. Yeah, if like we cannot use it here to reduce this integral. Rather, I think we can reduce this one as well. It's cosecant of x. Now, so there's a formula now. This formula relates to reducing the powers of secant to minus 2. We can actually find that formula by reducing the powers of cosecant by a factor of negative 2 again. So it works. But this one, generally, we are going to see how this formula is going to be useful to us in solving a difficult integration problem from MIT. So thank you for watching, and please do have a nice day. Bye.